Engines and motors regularly create a big impression, with their complex moving parts and the way they deliver serious power to a vehicle. So when these items of machinery are huge and installed in some insane and record-breaking things like trains, the reaction is something else. Want to know what provides the horsepower for some stunning modes of transportation, both from now and through history? Then check out our list of 5 insane huge engines and motors. General Electric GE90. Built by an American company, GE Aviation, which is linked to General Electric, the GE90 engine series represents the planet's biggest jet engines. They need to be big too in order to help the Boeing 777 take passengers across the ocean day in and day out. Developed at a cost of $2 billion, the GE90 stood out for being an original design. Competitors typically modify their older engines, whereas GE decided to go in a new and exciting direction, kind of starting from scratch in some ways. Where did the idea for the GE90 come from? It had its origins in NASA's energy-efficient engine of the 70s and made its debut with British Airways in 1995. The GE90 is so admired that a fan blade was put on display at New York's iconic Museum of the Moving Image. So it's a true design classic. And the story doesn't end there. The latest addition to the GE90 family is the GE9X, which, all being well, should be certified this year following a test flight last March. This enormous power source, intended for use in the Boeing 777X, generates 100,000 pounds, 45,359.237 kilograms of thrust. That's equal to approximately a quarter of that produced by one single space shuttle engine. It has a record-breaking front fan that measures an impressive 11 feet, 3.35 meters in diameter. The GE9X has the highest pressure ratio of any commercial engine and, as you'd expect, benefits from the latest technology. Its fan blades are carbon fiber and significant elements of the engine have been realized using 3D printing. This has helped GE create original and, most importantly, top secret designs relatively easily. CMCs, or ceramic matrix composites, have also played a big role. Because they're lightweight and heat-resistant, they improve efficiency and enable the GE9X to cope with temperatures up to 2,400 degrees Fahrenheit. This is one hot potato, of the mechanical kind. Pratt & Whitney R4360 Wasp Major. This U.S. classic was supposed to be used in World War II, with work starting on it in 1942. However, it took time for Connecticut-based manufacturer Pratt & Whitney to develop, and the world moved on in the process. With the conflict over before the R4360 was finished, it wound up being installed in the B-50 Super Fortress, among other planes. As the largest displacement aviation piston engine in America mass production, it represented the pinnacle of piston-based technology. Also called reciprocating engines, piston models take pressure and turn it into a rotating motion. The R4360 had 28 cylinders, each of which used 2 spark plugs, which helped with air cooling. The engine was 8 feet, 2.45 meters in length, and 4.6 feet, 1.4 meter in diameter. The R4360 is famous for being a relatively light engine, despite its substantial nature and impressive 3,650 horsepower. Weighing 1,544 kilograms, 3,405 pounds, it reportedly needed constant maintenance, with the mounting bolts needing to be tightened after each flight. That didn't mean it wasn't reliable, but gives you some idea of the engine's sheer power. In addition to the B-50, which was developed from the B-29D Superfortress, the R-4360 also powered the Boeing C-97 Stratofighter transport, the Douglas C-124 Globemaster II, the Fairchild C-119 flying boxcar, and Convair B-36 Peacemaker. It also lived on in the form of spare parts, so while this enduring engine didn't fulfill its original purpose of battling the Nazis, it certainly made an epic contribution to keeping American ingenuity in the air. Wärtsilä Sulzer RTA-96C. Large container ships are the workhorses of the sea, transporting millions of tons of cargo across the water every year. When it comes to engines, these vessels like to keep things simple and, most importantly, big. The Finnish company Wärtsilä has been servicing these needs since 2006 with their much-used RTA-96C, a Sulzer diesel engine that combines heavy-duty horsepower with energy efficiency. The RTA-96C is the biggest reciprocating engine of its kind, operating on either 6 cylinders or 14. It's 44 feet, 13.5 meters in height, and 87.2 feet, 26.59 meters in length. It weighs 2,087 t, 2,300 tons, with the crankshaft weighing 300 tons, 272.2 t on its own, and has 107 390 horsepower. The engine is what's known as a turbocharged two-stroke diesel. Sounds flashy, but what does this mean for the uninitiated? The two-stroke is when an internal combustion engine's piston completes a power cycle in 2 strokes, whilst the crankshaft revolves once. The turbocharging comes from an induction device that uses a turbine to drive additional compressed air into the engine's combustion chamber. This makes the RTA 96C more efficient, an essential quality in today's hard-working engines. However, this is still one mighty piece of machinery. It's reported that a 14-cylinder version guzzles 1,660 gallons, 7,546 liters of heavy fuel oil every hour. The RTA 96C employs common rail technology. What is that? Well, put simply, it is a digitally managed fuel injection system operating at high pressure, but which is designed to be more energy efficient. A peek inside the inner workings of the engine reveal it has an intriguing twist. Typically in an automotive engine, the top of the connecting rod is joined to the piston. Not so with the RTA 96C. Its rod is connected to a crosshead and then another rod links it up with the piston. The reason for this setup is thought to be so the crosshead absorbs sideway force from the connecting rod. This saves these forces being channeled onto the piston, which in turn can alter the shape of the cylinders as time goes on. A small move that makes a big difference in this truly huge and in some ways insane engine. Union Pacific 4014. If you thought the age of steam was dead and that steam trains were nothing but relics, then you haven't heard about the Union Pacific 4014. Originally built in 1941 by Alco, or the American Locomotive Company, the fleet of 8 went on to become legendary on the rails. This 4-cylinder coal-consuming train was a type known as the Big Boy. Why was it called that? In all honesty, no one is sure, but it sounds cool. The assumption is that a clever staff member stenciled it onto the side of one of the trains and it really caught on. The overall length of this huge powerhouse is 132 feet, 9 7/8 inches, 40.48 meters. Reportedly, it's 100 feet shy of a Boeing 747, which really gives you an idea of how awe-inspiringly large it is. The 4014 is 11 feet, 3.4 meters wide, and 16 feet, 2.5 inches, 4.94 meters high. In total, it weighs 1,250,000 pounds, 567 t. The Big Boy trains, which if you wanted to build them today would cost in excess of $100 million, were the property of Union Pacific Railroad, and the 4014 is the only one still running from those glory days. It has what's referred to as a 4884 configuration. That means it has a 4-wheel leading truck, i.e. the wheels are the front, 2 sets of 8 driving wheels, and finally a 4-wheel trailing truck. You've guessed it, the wheels are at the back. The 4014's main job was to transport freight across America's Midwest. However, it also took passengers and went as far afield as Los Angeles. They were super reliable, with some racking up over 1 million miles. Definitely a lot of coal. There was an attempt to use oil in them between 1946 and 48, but this phase of development never went beyond the test stage. In terms of accidents, the 4014 has a virtually unblemished record. Only one Big Boy was ever written off in the course of its service, and that's not the only survival story this amazing train has to tell. This year, the 4014 was fully restored and put back on the tracks, showing there's life in the old girl yet. It's now the biggest operational steam locomotive on the planet. Not bad at all considering the train went out of service in 1959, though it was donated to the Railway and Locomotive Historical Society and exhibited in 1961. To have lasted so long and to be resurrected for a new generation is an awesome and insane achievement. It also had lasting fame of a different and unusual kind when the Big Boy inspired a vehicle in the Galaxy Railways, a Japanese anime series from 2003. Haliad X 12MW. So far, our rundown of huge, insane engines has been more on the smoky side. From steam to oil, keeping an engine fueled is of course a dirty business. Some concessions have been made to reduce the environmental impact, but naturally people are looking at green forms of energy as the way forward for a vehicle's power source. Something lending credibility to this idea is the Haliade X12MW, the world's biggest and most powerful offshore wind turbine. The digitally controlled X creates approximately 45% more energy than the planet's most powerful wind turbines. The emphasis, as you can imagine, is on efficiency. In what's billed as the first of its kind, this turbine boasts a capacity of 12 megawatts with a 722 feet, 220 meter rotor and a blade measuring 351 feet, 107 meters. It stands at 853 feet, 260 meters in height. This combination of bigger proportions and a world-beating capacity means the turbine is effective against wind speed variations and even a lack of wind, factors which have plagued the turbine market since time immemorial. The design, coming from Danish company LM Wind Power, enables the turbine to run at 63% capacity, putting at least 5 points above what the industry demands from the next generation of energy providers. But how powerful is it exactly? According to the publicity, a single Haliade X can provide power for no less than 16,000 homes. It can also generate a reported 67 gigawatts every year. Another goal behind this development is to show the true value of wind to the consumer, if the right equipment is used to convert this temperamental natural resource into energy. By using smart tech and a clever design, it's believed an insane amount of around $26 million can be sheared off the average cost of a wind turbine. Insane huge engines and motors are what everyone relies upon to maintain modern life, and it looks like the future is going to be bright too, with innovative green technology playing a part in generating clean energy for years to come. If you liked the video, then click the subscribe button and turn on notifications, and you'll be the first to know when we release a new video. Thanks for watching, and we'll see you next time.